is bigger than the denominator.
Numerator is bigger than denominator. Give me an example.
6/5.
No, the same one. 6/5, very good. 6/5, that was perfect. All right, so that is an example of a mixed number. A mixed number is when you have a whole number and a fraction together. Are they two different numbers? Is that just one number?
No.
Yeah, it's just one number, isn't it? It's just one, it has one value. 1 and 1/5 is just one value. It can be represented at a particular point on a number line. If you had a number line here with 0, 1, 2, 1 and 1/5 would lie about here, wouldn't it? And 6/5 would also lie there. That's the same place. So don't be confused that these are two separate numbers. It's all together in one number. It has one value. It can also be written as 6/5, where the numerator is bigger than the denominator. That is an improper fraction, where the numerator is bigger than the denominator. Okay. How do we convert between these two? So if I give you one such as, if I have 2 3/4, and I want to put that as an improper fraction, can anyone give me a method how I might do that? Sorry.
You would times the denominator by the whole number.
Okay, yeah. Why would I do that?
Because 4 goes into, it already went through it 2 times.
Yeah, you're on the right track. Well, if I wanted to represent this in visual terms, let's say we were just dealing with boxes, I would have 2 full boxes and 3/4 of a box, yes?
Yeah.
Yep. So how many quarters of a box do I have? Well, if I turn these into quarters, I go, oh, I got 4 here, and 3 there. So my total would be 4 and 4, that's 8, and 3, that's 11. I have 11 quarters of a box, yeah? 11/4. Well, there's the short way of doing that and say, well, I've got 2 4/4s. So what you do is you think, all right, this 2 can be multiplied by the 4 to say I have 2 4/4s. And then I can add that number to the top of the fraction. So I multiply the whole number by the denominator. So whole number, m, times denominator. And then add to numerator. NUM for numerator, the top of the fraction, DEN for denominator, if you're not sure how to do it. So what I did was 2 times 4 gives 8, added to the 3, I get 11. So this one converted is 11/4. Let's just do one more, I'll just do it over here. What's 4 1/7 as a improper fraction? Max? 25? Nilu? 29. Okay, yeah. So 7 times 4 is 28. Added to the top, I get 29/7. They are the same number. Yes. Okay. That is how we convert from a mixed number to improper. We multiply the whole number by the denominator and add what I get to whatever the numerator was. How do I go the other way? If I have an improper fraction, so let's say I have something like 17/3, how do I convert that the other way? Okay, Nilu?
See how many times the denominator fits into the numerator, and then the leftover there is the fraction. For example, the 3 fits into the 17 5 times.
Mm-hmm. Great. Okay. So to work the other way, if I have an improper fraction, I have to use some sort of opposite thing to here. So math's all about opposites. If I go one way, if I multiply one way, I should be able to divide to go back the other way. If I add one way, I should be able to subtract. So if I've multiplied going this way, I should be able to divide to go back to what I want. So I want to find out how many whole 3/3s there are in this. So that would be a division. How many times 3 fits into 17? You don't have to write this out. Probably you could do it in your head. 3 fits into 17. 5 times, isn't it? And I have this remainder of 2. Well, the remainder is what's left over the fraction, isn't it? So I have 5 whole, and then I've still got 2/3 left over. Yes? So 3 into 17 goes 5 times, the remainder 2. So to go backwards for improper to mix, I divide by denominator, don't I? And then I, whatever the remainder is left behind is over denominator still. Okay, so I kind of presume that you know that. So 17 over 3, I'll remove this one from over here. It is not a mixed number. 17 over 3 goes to 5 2/3. Remove that too.